So one of the most common and dangerous types of attacks is called cross-site scripting. And once again, cross-site here refers to the fact that one site is sending a script that gets executed in the context of another site. And that is where the cross comes from. And the script is being injected by an attacker into a vulnerable website, or rather into a page returned by a vulnerable website. And there are different types of XSS attacks. Reflected means there is a request that is submitted, and part of the request is somehow included in the response, and that's how a malicious script is injected. Persistent means it is stored. The malicious script is somehow stored as data on the server side and reused. And DOM-based is something that we will talk about as we go further along. So the XSS is a code injection attack. So the attacker is able to inject their code, and you can understand from our earlier discussions of code injection in binary code injection attacks that code injection is a very powerful type of attack and gives attacker the ability to do pretty much anything. And so XSS is something that gives the attacker complete control over the page that's being returned. And the most common or the easiest thing for the attacker to do is to steal your cookie, because they can simply send the cookie to an attacker website, right? So they inject a script. This script can, as you know, can connect to any site, and therefore it can connect to the attacker site, and it can send a parameter whose value can be document.cookie, and that way the session cookie, for instance, can be sent to the attacker, and now the attacker can take over your session and impersonate you, and perhaps if it's a bank, they may be able to operate on the bank account and steal money and stuff, or if they are if it's an e-commerce site, they may be able to order in your name and things like that, right? So that's one of the common things that they can do, but they can also change the page. They can steal all the data that's available on the page. And there's, sky's the limit. They basically can do anything with that page. So let's look at what is a reflected XSS. Let's look at that with an example. So we have seen examples of reflected XSS a while ago when we were looking at injection vulnerabilities. So basically, let's look at it more carefully now that we have some idea of how the web works and how the same origin policy works and so on. So consider a site which basically presents a form, and the user simply types in their name on the form, and it basically the website responds with another page saying, welcome user, welcome to our system, right? So in this case, when the user fills out their name, then and presses submit, a GET request may be sent to the web server, which includes a form parameter name, and its value is whatever you filled in. So this %20 is the space character, right? So on the receiving side, it's going to construct a web page where it's going to basically extract this parameter value, and it's going to just echo that parameter value over here, right? So this is the reflection part, right? So it's taken, some content is taken from the request, and it gets reflected in the page that comes back to the user. So this is how the simple website works. So, but what if the user submits a query like this, where name has this strange looking value which actually happens to be JavaScript code enclosed in these script tags. Okay, so then what's going to happen here is that instead of the name here, there is going to be a JavaScript, and this JavaScript code is then going to be executed on this page, right? And because it's going to be executing on a page from vulnerable.site, then it's going to have be able to access all of the data and cookies of that site. So if you look at this attack carefully, there is one thing that doesn't make so much sense, because it looks like the attacker is just the user, right? Because it looks like who's going to submit this request? Well, it looks like basically the user is submitting this request and the user is getting back a page. And how does it help the user to attack themselves? So in order to understand that, you sort of have to realize that the way these types of attacks are going to work is that some attacker is going to construct a request like this, or construct a link with this type of information, this type of content, and then what's going to happen is that the attacker is going to get the user to click on that content, and so the user doesn't really know that they are putting in this script in there, but so basically they are being phished or tricked into doing this. So the first step typically is that the attacker causes the victim to click on a maliciously crafted link. Right? So this link often will submit a GET request such as this one, right? But more commonly, what may happen is that the link may take you to attacker's web page, and the attack is then completed from that web page, because within the attacker web page, the attacker can not only submit a GET request, they can also submit POST requests. So they have a lot more power to do whatever they want once you are on their site. So once this has happened, so that the malicious request has been initiated, then it goes to the vulnerable site, and then obviously the vulnerable site is not checking the input carefully, or else it'll realize that some random script is getting injected. So obviously for this attack to work, the website should have a vulnerability in the way it checks its input. And because of that vulnerability, it returns a page that contains the malicious script that was injected into this malicious link. Okay, and now this script can perform any action that the user or the website can perform. So that is the reflected XSS, where the script is already included in the request that is submitted to the vulnerable site. A persistent XSS is different in that the malicious script is no longer part of the request, but the attacker has carried out an attack that caused the script to be permanently stored on the server. Right? Sometimes it may be stored in a database, sometimes it may be stored as a file, but the point is that it's already there, and then the attack happens whenever an unsuspecting user goes to a page, and in that page, when rendering that page, this stored script is being used. Okay, so again, the two requirements are there must be a setup step, a setup attack that causes the script to be stored somewhere on the server, and then there should be another web page that the victim user can visit, and when they visit, this script content is going to be used there. Okay, so how is this going to happen? Why would the script be stored, and why would this be used in the page that is being shown to the user? So one context is a social networking or a blog site, right? So you have in a blog site, you may have a blog post, and then you may have a number of comments from different users. So what if one of the users is an attacker, and they include in their comment something uh, you know something like this in their comment, right? So when rendering their comment, it is possible that this exact text will be rendered there, and therefore the attacker's script will get executed each time a page containing the attacker's comments is shown, right? So you can see that many users will visit a blog page, and each time they'll not only see the original post but also all the comments. And when there is this attacker's comment is shown, then the attacker's script is also getting executed, right? And the reason why this is possible is because many blog sites do allow you to include HTML tags, and so it's conceivable that a script tag may be there, and it is not checked carefully. But it's more likely that it is checked, and so in fact most blogs will, of course, even if they permit HTML tags, they do check, and so it is not something that you're going to be able to do very easily. But there can be situations, conditions under which this check for script tag may be subverted, or maybe incomplete, or maybe you got to a really bad blog site where the script tag is not even being checked. And in those cases, there is an easy way to carry out a persistent XSS. So now let's look at what is DOM-based XSS. So a DOM-based XSS is sort of, this categorization is orthogonal to reflected and persistent XSS, right? So it refers to how the script comes about, not about where it comes from, right? So in the case of reflected XSS, the script came from the request. In the case of persistent XSS, the script came from some place already on the server side. So in the case of DOM-based XSS, the script may come from anywhere. That's not the point. The point is, how is it getting put in the return page? In the case of plain XSS, the malicious script is already there in the HTML text that the server returns. In the case of DOM-based XSS, the script is not there in the page that is returned, but it actually shows up when the scripts on that, when benign scripts that already exist on the page, when they execute, they may end up creating these new scripts, which are the injected scripts. So how does this happen? This happens because you may have heard of this Web 2.0, where the web page is not fully constructed when it is returned by the server, but instead when the page starts executing on the client side, or in particular, the scripts on the page start executing on the client side, then these scripts then construct the rest of the page, and that is when these new scripts come into force. So we have already seen operations like document.create, create element, document.append child, which may be used to gradually build up the content on the client side. And when you build up the content on the client side, you may be constructing this content from the content of variables and other data that's obtained from the server side. And so as you put these pieces together, you may end up introducing the script element at that point. And in that case, if this script is created dynamically, then it is called a DOM-based XSS. So now that we have talked about different types of XSS, the next question is how can you prevent it, right? So obviously, XSS is a vulnerability because it involves a server that is not carefully checking some input that ends up being a script. So in particular, the server has to be very careful in the information that it sends, in the page that it sends to the browser. And it should make sure that any script content that is included is in fact something intended by the server side, and it's not something that is injected there by an attacker, right? So so that's how the vulnerability on the server side must exist in order for this attack to happen. What we are going to try to show in the next few slides is how easy it is to inject scripts into web pages. In particular, there are many different contexts in which scripts can be injected, which makes it very difficult to check whether the input from user is being used correctly. Okay, so in the examples we are going to show use a particular notation. We are going to use evil script as a placeholder for a malicious script. %var is going to be denoting places where HTML templates are instantiated with server-side parameters. And using this, we're going to show how in different contexts XSS can occur. Okay, so the most simple case is there is a parameter that is sent and that parameter is reflected. Okay, so most web pages these days most websites these days are written using some kind of a web application development framework. You may have heard of many such frameworks. I'm not going to talk about anything in specific here, but the main point is that they all use template HTML, which means that most of the static content of the web page is already there, but there are sort of placeholders where something that's dynamic on the server side, right? Something that changes on the server side can be inserted, right? And often this kind of notation is used. So the way this is going to be interpreted is that when this page is rendered, the server side is going to interpret something like this as a variable. So if there is a variable named query, and that variable has a certain value, then when this template is rendered, it's going to, the value of that variable is going to be substituted here, and then it's going to be rendered. Okay, so now if the value of the variable query happens to be a script, then you're going to just render that script, and that's the simplest case of how this attack takes place. So another place where scripts can be injected is a tag attribute. So for instance, so look at this, right? So there is a input field which has a parameter name and a parameter value. Okay, and it is on the template when it's constructing the template. This is a constant, and here is some value that the user provided at some point earlier on that has been stored in a variable called city. Okay, so if the attacker now sets city to be this value, then when the substitution is performed, then you end up with something like this. And now you can see that what the attacker has done is they have closed this tag value, right? So, when you substitute this value over here in the place of city, then you end up with something like this, where the value now becomes XYZ, and then a script is introduced here, and then the form ends. So now the attacker script has been introduced into the page, and all the attacker did was to control the value of some form field. So another example is in the scripts can be injected in event handlers. So maybe here is template page. Maybe this website allows the user to use their own background or image, and therefore this image URL variable may be set and may point to the file holding this image. And if the attacker can set it to the value, this whole value, then when this whole value is substituted here, then you're going to end up with a tag that looks like this: image source equal to such and such, on error equals evil script. Now all the attacker has to do is to make sure that this is either an invalid script or invalid image, where trying to load the image will cause an error. And once it causes an error, the web page is going to invoke this on error action, which ends up executing the attacker's script. So and there are many more ways to inject scripts. So I'm not going to go through them in detail in the lecture, but I encourage you to go through all of these to sort of get a better idea of how these scripts can be injected. So now, if you want to defend against XSS, one of the common things that is done is blacklisting, meaning that certain bad input is not permitted. So one of the things that is often done is that in the parameters, you can check whether these less than, greater than symbols are present, whether a script, the word script is present, whether document.cookie is present, and so on. So this kind of blacklisting is of course often acceptable, but it is rarely complete. And that's because there are many different ways to introduce scripts, as we just saw, and there is no way to blacklist every one of them. And that's why blacklisting is not a very good choice if you want to build, if you want to avoid XSS vulnerabilities. Whitelisting is, of course, a better approach, where you say, okay, this particular parameter needs to have a certain form. So for instance, a parameter may represent a number, and then you may insist that this parameter value be a number and nothing else. And when you do that, then there is you preclude the possibility of an attack, because if you just give a number where a number is expected, there is no way to inject a script in that case. So that's always going to work. The practical problem is that there are going to be contexts where you want to allow free form input, and in that case, whitelisting may not be possible. But the main point here is that whenever you have a parameter that has a limited values, such as a number or a string with alphanumeric characters but no space or other special characters, then you should enforce that, because then at least you're making sure that scripts cannot be introduced in those contexts. So a third thing that is done is escaping user input, right? Because in order to inject a script, you always have to use, somehow the attacker has to put this into the page. This means that you have to inject these greater than and less than symbols, and these symbols, you can find them and you can encode them into for instance, there are these HTML entity encodings for all these special characters, and you can use them to encode them. And if you do that, then even if they are reflected in the page, it'll no longer be this less than, but it'll be some kind of encoding. And then the browser will no longer interpret that as a script tag. And finally, there has been a new proposal called content security policy, which we talked about in the context of same origin policy and CSRF and clickjacking before. So the CSP is another approach which can prevent these unauthorized scripts from entering a page. Okay, so what is content security policy? It's a new standard that was introduced maybe about 10 years ago, and it's currently supported by most browsers. In the context of XSS, what content security policy does is that it tells the browser that what are the allowable scripts on the page. Okay, so the first version of content security policy didn't allow inline scripts at all, and this made it quite difficult to use because most web pages have a lot of inline scripts. So a revision was introduced called CSP v2, and in CSP v2 they allowed inline scripts and then provided a way to list what is an authorized inline script, and that enabled CSP v2 to be effective against XSS. Okay, so there are two types of inline script related information. One is a nonce, and the other is a hash. Okay, now both the nonce and the hash are provided in the HTTP header. Okay, so in the case of script, it says, okay, here is a header that describes the content security policy, and it says that the script source, all script sources should have this particular nonce. Okay, so this nonce is dynamically generated at the time the server produces the page, and therefore if any content that the attacker injected cannot have this nonce because the attacker doesn't know this nonce value. And so what's going to be done is that in the page, the browser will only make use of scripts whose nonce value matches this nonce value provided in the HTTP header. Any injected script will have the script tag, but it won't have the nonce that matches this nonce value, and therefore those injected scripts will be recognized as imposters and not be thrown away. The second way to authenticate the scripts is by taking a hash and storing that hash, providing that hash as part of the HTTP header. So in this case, the content security policy says that the script source should have this particular hash value. Okay, and this is the hashing algorithm SHA-256, and this is the hash value. And so when the script is parsed by the browser, it's going to basically look at compute the SHA-256 of the script content, and then it's going to compare it with this particular value, and then if it matches, the script is going to be considered authorized. If not, the script is going to be considered unauthorized and basically tossed. So there is also a second approach that browsers implemented themselves, specifically against reflected XSS. So so the idea was that websites often have some vulnerabilities, and so the browser vendors said, okay, if there are ways to detect some of these exploitations, why not stop that? And so Internet Explorer was the first one to introduce it. Then Chrome followed a bit later, and then Firefox invested in it at some point. In fact, it's one of my students who went there and built this XSS filter for them. But in the past several years, maybe because the CSP has become more popular, the interest in making these XSS filters more powerful has waned, and so there is not has not been as much development on these filters anymore. But it is still useful to understand how these reflected XSS filters can work. So the very first approach is to simply look for suspicious content within request parameters, right? So for instance, is there less than script greater than, is that there? Or is there a data colon? Because data colon is using that type of a URL, you can inject a script. So you may be familiar with this Firefox add-on called NoScript, and NoScript basically uses this approach. The problem is that there can be many contexts where this is legitimate content. Even this could be legitimate in some contexts, and so to blindly say that it's wrong to include anything like this leads to high false positives, and so basically it's not going to work with many websites, and so people are not going to use it. Okay, so maybe some really paranoid people might use NoScript, but it's not something that's widely used. So Internet Explorer and Edge came out with an improvement over this approach. So in addition to checking whether there are these unusual or potentially malicious content in parameters, it also checks whether this potentially malicious content is reflected, right? So if it is just goes into the server and the server has proper sanity checking and doesn't ever put this kind of dangerous content back on the page, then well, there is no need to worry about it. And so by incorporating that additional check, IE and Edge reduced the false positives quite a bit. But unfortunately, this led to false negatives and ways to evade these filter. So we, in our approach that was implemented into Firefox, we refined this further. So in particular, we want to see this condition, that is dangerous content should be there. It should also be the case that this dangerous content should be reflected. But finally, we also want the dangerous content to be used in a way where it can be interpreted as a script. So by combining all three criteria, what we are able to do is we are able to come up with something that is doesn't have many false positives at all, and at the same time it is also able to evade this kind of filters. Okay, so what I mean is that it has low false positives, and it also has low false negatives because the filter evasion techniques we are able to take care of them because of the following reason. So because we have already have low false positives, we can make the checks much more precise. And when we make that much more precise, these evasion techniques no longer work. So we talked about cross-site scripting. That's not the only way to inject a malicious script in a page. Another way is, the website may already include a script, right? So that is a script inclusion. How do we know that the script that is included by a server is, not malicious, okay? So one of the common things that you may have noticed is that there is this, toolkit called jQuery that is widely used, and very often, websites use, these jQuery scripts, and often these jQuery scripts are not hosted on the same server. They are coming from a third party. And the question is, what if the third party turns out to be malicious, right? And it's not just jQuery, but like if you add a like button, then that's some script that comes from some social media site, and so on. Okay, so this is typically how you would include that script. So this is the intended content. So it's not an XSS situation. The server really wants this script to be included. The problem is that where the server does not have really control over foo.com, right? And therefore, it is possible that the script that is delivered by foo.com is malicious, right? So why would it be? Well, maybe foo.com itself is malicious, and that's why it's a malicious script. But more likely, what could happen is that the organization running that site may go under, and somebody else may buy that site, and then their goal maybe is to use is to basically maybe in e-commerce crime, and so they may be using on purpose replace all the scripts with malicious ones. Alternatively, if it's not legitimately taken over, it may be a case where an attacker compromised foo.com and then replaced these scripts with malicious ones. So yet another type of attack is called a timing attack, and the timing attack is a case of what are called side channel attacks. Okay, so these are used when there already exists a policy that prevents the attacker from directly getting at the information that they want, right? For instance, if the attacker wants to find out whether you are currently logged in on Gmail, there is no way for them to do that because gmail.com related information cannot be seen by attacker.com scripts. So they can try to circumvent this by using a timing attack. So let's see how that can work. So suppose the attacker puts this image, this tag on their web page. So the browser, when it sees this particular URL, it's going to go to that URL and fetch that page, and then it will check whether it's an image or not. Okay, so it takes some time to go and fetch this information unless the browser has already recently visited the page, in which case it may be cached, and therefore this may take a short time. So based on the amount of time this load takes, the attacker may be able to find out, how long it's going to, whether the user is already logged in or not. Okay, so so this page simply describes this attack in more detail. So that is, we looked at several examples of attacks that can be launched by an attacker on the web. So we started with CSRF, then we talked about XSS, script inclusion, and timing attacks. So we'll stop with this on this class of attacks, and then move on to the threat model 2, which is the network-based attacker.